Okay, this is Mr. Long again, and we're going to try to finish up on Lewis structures. After we finish this third video, there will be a practice sheet or practice worksheet where you found these videos under Lewis structures. And this is just a little paperweight. I think I love all things Egyptian, or that look Egyptian anyway, for that with the pyramid. Now, let's pick up with a double or triple bond. Let's look at O2, the molecule oxygen. And let's see, let's get a little bit closer. Oh, we are closer. Okay, so now we're going to do what we've been doing. We got 6 valence electrons from group 16 times 2 is equal to 12. Now, by the way, get out your periodic tables. If you don't have them out, that will just help a whole lot, unless you have the first 20 elements memorized. So we've got 12 electrons. So there's only one way to do this. Put them side by side. Give each one 8, and then we'll see how that works. Okay, so now each one of these has 8. That's what it wants according to the octet rule. Well, let's add these up. We have 2, 4, 6, 8, 10, 12, 14. We got 14 electrons. Uh-oh, they're not the same. Okay, so we are short from doing this. We are short 2. And if you're short 2, you're going to make a double bond. If you're short 4, you're going to have to make a triple bond. So short 2 is equal to a double bond, which is going to be this right here. And then short 4 is equal to a triple bond. So we're going to have this right there before we convert them into lines. That'd be 6 electrons. So anyway, we're going to put the double bond in the only place that we can, in the middle. So let's write this again, and let's put our 4 electrons right here. Now what that means is both these oxygen atoms have 4 electrons. They're sharing. Sharing is caring. And then we want to give them, make sure they have 8 electrons. That's 2, 4, 6, 8. And do this. 2, 4, 6, 8, and that will work. So you would think that we have that, and we're going to put these electrons at the corners. Electrons are these negative particles, and they repel each other, and they want their elbow room. So it's going to sort of look like that. But I'm sure your drawing will be better. Let's look at nitrogen. N2. Now N2, count up your electrons, and you can pause me so you can count them up. Go ahead and pause it. Alright, and so what we had there was 5 group 15 times 2 equals to 10 electrons. So you're going to do it side by side, and you want to give them 8 electrons and see how that works. 4, 6, 8, 10, 12, 14. We got 14, and that's a no-go. So we are short 4 electrons, which means a triple bond. So we're going to put our triple bond in here like this. And these electron pairs will be on the very end. And then we write our final formula. As such. Okay. And that is the Lewis structure for N2. Now let's look at carbon monoxide. So CO. So let's do CO here. And let's add these up. Carbon is equal to, it's group what? Group 14. So 4 times 1 is equal to 4. And then we're going to have oxygen, which is equal to 6 times 1 is equal to 6. That's 10 electrons. So you can only put them side by side and give them each 8 electrons. I think you guys can do a better job of putting these electrons in place than I do. So 2, 4, 6, 8, 10, 12, 14. We are short 4 electrons. That's a triple bond. So put carbon triple bonded to oxygen with your pairs on the side like that. Well, let's do carbon dioxide. Let's see here, and I hope you guys can see this. CO2. Carbon is equal to 4 times 1 is equal to 4. And the big O is equal to 6 times 2 is equal to 12. That's 16 electrons. Now, if you got 1 of one kind and 2 of another, almost always that one's going to be in the middle, and it's carbon, so it's certainly going to be in the middle. Put your 2 oxygens on the outside like that. And let's do what we normally do. Try to give each one 8 electrons. Two, 4, 6, 8, 10, 12, 14, 16, 18, 20. Well, short 4. So, but there's no one place to put the triple bond. That being considered, you've got 2 equal places. So you want to keep symmetry, if at all possible. So we'll put in 2 double bonds. Like this. So carbon's already satisfied. Now this guy's got 8, like that. Carbon's got 8. 8. So they're all satisfied. And let's count them up. 2, 4, 6, 8, 10, 12, 14, 16. So we're good. A final form. Like that. So I'm going to give you guys some problems to work, and I'll upload that shortly after I do this one. And we'll see how that goes. So adios for now.